All right. So, oh, sorry, let me see if I can move this around here. Oh, I wish I had a cameraman that would actually point this in the right place. Anyway, hopefully you can see most of the board there, and it'll come in focus in a second. So we're going to do 4.2, which stands for least squares regression. Okay? Now we're going to talk about, actually, I don't know, I probably should have used the word ordinary in the first. Ordinary least squares regression. OL, it's often referred to as OLS. Okay? So the idea here is, this is the best fit line for your scatter plot. Now, as we mentioned yesterday, scatter plot's kind of your preliminary analysis. What we're looking for is we're hoping that our data fit a straight line. And now if it looks like it does, we're going to move on to regression. We're going to find that line. Okay? So you probably are all familiar with the equation y equals mx plus b. You guys all remember that equation from Math 1010 or whatever? Okay? So we need to figure out what is the m, what is the b. Now in the book, they write it as y equals b0 plus b1x. Okay? So all the equations are in b0 and b1, but it's the same thing. It's exactly the same thing. I like to use m and b because that's what you guys are familiar with. And so I'm going to use it in terms of m and b, but in the book it's got b0 and b1, but it's the same thing, okay? All right, so now to find the slope, m, or in the book it calls it b1, okay? The equation is r times s sub y over s sub x. And the y-intercept, which I like to call b, but calls b sub naught, same thing, is going to be y bar minus m times x bar. Okay? So let's just go over that really quick. All right, we might cover 3.2. Is that really out of focus? Was that ever in focus here? Focus on me? Well, it might be out of focus. I don't know why. All right, so here's what I want to do. Is I want to share my screen here. Go ahead and open up the thing that I said yesterday, the 4.1. And we'll just briefly review yesterday very quickly. If I can learn how to share my screen. Share. Okay, so this was the equation we did yesterday with the golf club swing and how far the ball went. So who remembers? I'm going to pick on Kyle. Do you remember how to create a scatter plot? You don't remember? You've been struggling with that one? Well, you probably should select your data, right? You should also enable editing because otherwise it's not going to let you do anything. Okay, select your data, and then what do you think? Insert. Scatter. Just like that. Now, do you remember how to put titles in there? How do you do that? The plus sign. Axis titles. So down here we've got club head speed, which is in miles per hour. Make sure you put the units in there so people know. And this is what? Distance, which is in yards. Okay. And this is golf club swing on 70-degree day with no wind. Okay. All right. So we look at that. Yesterday we did our correlation. It seemed like it was pretty strongly correlated. And it looks like, would you agree that it looks like a line fits there pretty well? Okay. Oh, it doesn't say it, but that's what it is. It's miles per hour. Okay. Yeah, it says it in the book. I didn't copy it on the spreadsheet there, but yeah, this problem's out of the book. Okay. All right. So now we want to figure out. So let's talk a little bit about ordinary least squares regression. Okay. The idea here is it minimizes the vertical distance. Okay. So let me just show you here really quickly. I kind of wanted to hold off doing this, but I know that Eric already knew about it because he said you can draw a trend line. Do you remember how to do that? How do you do that?
Just press press on the plus sign where it says trend line. You want to you hit that arrow linearly.
Oh wow, he shot me a new method. I never noticed before. Wow, so you got trend line right there. Okay. Okay, I don't want to hit that yet. You're jumping ahead of me, but yes, you're right. Okay, so study with Eric. He knows what he's doing. All right, so we've got this line now. Excel draws this best fit line. So the idea here is so we're minimizing, I spelled vertical wrong. We're minimizing the vertical distance. So the distance from this point to that line, or from this point to that line. So we're doing the vertical distance. Now, as I draw this here on the board, okay, if I've got a bunch of dots here, okay, I'm minimizing the vertical distance, okay? Now there's lots of methods I could choose. I could minimize the horizontal distance, such as this here, okay? Or I could minimize, one more color, purple. I could minimize if I made that a right angle, the orthogonal distance. Which one is the best? The vertical is the best, okay? And we're going to do a demonstration maybe today. We're doing actually pretty good on time. Probably today we're going to do this, and you're not going to like it, but it shows you that vertical is the best, okay? So here's what we're doing. Let's first find the equation of the y equals mx plus b line, okay? The regression line. So in order to find that, I need to find the regression. Now, I don't think yesterday I showed you the cheater method, did I? Okay, so just as a reminder on the test, do you think I'm going to let you use the cheater method? You can check yourself, but if that's all you do, how many points are you going to get? 0 points. Okay. Would you like to see the cheater method? No? I don't want to do the whole thing by hand, so we're going to do it today. So here's the correlation coefficient. So it's going to be equals CORREL, coral. Okay, now it's asking for array 1. Array 1 is your X data. Then you're going to press a comma, and then you're going to do array 2, which is your Y data. Okay? So you can check yourself on the test, but just don't, you better do more than that. Okay? Because we covered that yesterday. I'm going to kind of pass by that. Yes? Coral, C-O-R-R-E-L. Just start spelling coral.
Then you highlight all the data.
Then you highlight the X data, you do a comma, then you highlight the Y data. Okay? So I got that value there, 0.93896. I'm glad I didn't teach you that yesterday. You'd all done that for your homework, and you wouldn't have practiced. Okay? All right, so the equation here, the slope equals R. I also need the standard deviation of Y and the standard deviation of X. In fact, we need the standard deviation. We also need the mean. Standard deviation equals the STDEV of the Y and the X, and I need the mean average of the Y, of the X and the Y. So I still need all this stuff, okay? All right, so now, in order to find the M slope M, okay, that is simply my correlation coefficient times the standard deviation of y divided by the standard deviation of x. Okay, so it says my slope here is 3.1661. Now I need to find my y-intercept b. What's that? Slope is written right here, r times s sub y over s sub x. Okay, just using these formulas right here on the board. Okay, now Victor, since you want me to slow down, okay, so can you help me with the y-intercept b? So this is y bar. Okay, you want me to skip you? Ashley, can you help me? What's y bar? And in this case, the y bar is 266 minus my slope, m, okay, times 101. Perfect. Okay, so I've got it now here. So what is the regression equation here? Give me the y equals mx plus b equation. Y equals, okay, thank you, Eric, 1661 times x minus 55.7966. Okay, so that's the equation of this line here that I drew in blue. Okay, or the Excel drew. Okay, does that make sense? Now, would you like to check your answer? Okay, you need to know to do the method that I just showed you. If you right-click on any point, you can go to add trendline, which I just did. And I think this takes you to what Eric was telling you at the beginning of your class, okay? You can display the equation of the chart. Look at that. That's exactly the same equation that we got. You can also display the r squared value. Eric was asking about that earlier today, okay? What do you think the r squared value is? Tanner, it must be your turn. What's r? Yeah, that's your correlation coefficient. So r squared is going to be your correlation coefficient, literally squared. Okay? Now in the book, this is actually, we are going to jump on to 4.3 today. This is actually called what we call the coefficient of determination. But I'm going to tell you something. Nobody I know ever calls it the coefficient of determination. They always call it the r squared value. Okay? And what it does is it tells you the percent of variation explained by the model. In our case, the model is y equals mx plus b. Okay? Or in our case, the actual values, we got y equals 3.1661x minus 55.797. Okay? So what we're saying here with an r squared, and by the way, just to prove this, okay, my r squared value, oops, I put f squared, r squared, is literally, if I take my correlation coefficient and I square it, 0.8815, look at that, it matches. Well, apparently they truncated it a little bit. They rounded that one and truncated that one. Okay? So the idea here is when you swing a golf club, okay, like let's look at this one. There were 2 times we swung the golf club at exactly 100 miles an hour. Okay? One time it went well, actually we can see. One time it went 257 yards. The other time it went 263 yards. Okay? Now, why would it go 2 different distances if I swung it exactly the same speed? What's that? The angle? Oh, it could be the angle of the ball. That's a good thought. I hadn't thought of that. Okay. What are some other reasons that could have caused the difference in distance? Sliced it, spinning. You guys are like way too technical. Maybe he hit a pebble and it bounced backwards, or he hit a pebble and it bounced forwards, or maybe it hit a little wet spot, or something like that. Okay. So what we're saying here, because this is, if this was perfectly correlated, all of those points would be on that line. But we've got the distance between here and here. That is what we call a residual. Residual equals the observed minus the expected. Okay? So one time, in fact, look, you can see that dot's almost on the dot, and these two are, in fact, the two endpoints are almost exactly on the line. The other ones, there's a little bit of variation. Okay? Now, what I'd like to show you, because I know that nobody believed me, okay? Ordinary least squares is the best fit line, okay? So we're going to do an exercise, and you're not going to like it, and you're going to think, I'm just going to miss that on the test, and then it's going to come back in chapter 14. You've been warned, and you're going to be like, oh, I hated that, okay? All right, so so I want to create what's called a residual plot. This is actually 4.3 that we're talking about now, which is residual plots, I think is what it's called. Residual plots. Okay, so we need to figure out what is the residual. Okay, in order to find out what is the residual, I need to find out what is the predicted. Question?
Before you go on to that, explain how you do the slope and
The slope and the y-intercept, I've got these two equations right here. It's as simple as that. Y, the intercept is m. Here, I'll do it again. So this is your correlation coefficient, which we found here, times your standard deviation of y divided by your standard deviation of x. Okay, and then this one is y bar minus m, which we just found here, times x bar. Okay, so that's the equation that we've got there. Oops, I put a C there, that should be an X. Okay, yes. They are all on the paper. Okay, so you don't need to memorize them, but you should be very familiar with them. I might make you memorize them for the quiz tomorrow, because there's only two, those are easy. Maybe not, we'll see. All right, I'll have to decide if I'm giving you a thing tomorrow. Okay, so we're going to talk about a residual plot. Okay, so here's what we're going to do. I need to find the predicted. Now, as I mentioned here, we can see here if it goes 100 miles an hour, you would see that it probably should have gone about 261 yards. Do you see that according to my regression line? Okay, so here's what we're going to do. We're going to use this equation y equals mx plus b. So y equals slope, which in this case is my m. I'm going to f for that, times my x coordinate, 100 miles an hour, and then I'm going to add my y-intercept. I'm going to f for that. Okay? So you can see here, according to my regression line, if it was right on the line, if I hit it 100 miles an hour, it would be about 261 yards. Does that make sense? Okay, so I'm going to copy that down. This is my predicted. Then I'm going to figure out my residuals. Okay, the residuals, as I said, was the observed minus the expected. So I'm going to take my observed. I observed when I swung at 100 miles an hour, it went 257 yards. I'm going to subtract off my predicted, or my expected, okay? Went 260, so it was off, my prediction was off 3.8 yards. Okay, does that make sense?
Could you do the predicted again?
I'll do it again for the next one. So this is your slope times, oops, I need to F for that one. Slope times your X plus your Y-intercept. By the way, I wrote this equation wrong. That should be a minus. Well, it's a plus or minus. I'll write it that way. How's that? Okay. Oh, so that's the same value there. So I got it twice. Okay. Now I'm going to copy this down, and you can see that these are, so some are positive, some are negative. Okay. So what we're going to do now is we're going to figure out the residual squared, because I don't want to worry about negatives. Okay. So I'm going to take this number here and I'm going to square it. And I'm going to copy that down. And then I'm going to find the sum. Okay, my sum here works out to be 49.8576. Okay, that's going to be on the test. Now, what you can do is you can create a residual plot. So I'm going to take my speed here, my x values. I'm going to hold the control key down, and I'm going to plot the residuals squared. Not the residuals, that's the residuals squared. Okay? I'm going to create a scatter plot. And this one I'm not so worried. Oh, you know what? I did that wrong. Sorry. I was wrong. I want to do the residuals. I want to do the residuals. This is why it's called a residual plot. I'm going to insert my scatter. Now, as you look at that, does that look like a null plot to you? Yeah, is there any pattern going on here? Okay, that's a good thing. So a residual plot, we hope for a null plot, which indicates random error. Okay, we want random error. Okay, so here's what's bad. So bad is to see a pattern. You see a pattern such as what we refer to as the megaphone. It could be a megaphone like that, or it could be a megaphone like this, or some other pattern. Okay, if you see a pattern, that indicates the error is not normally distributed. And therefore, linear regression should, I'm going to say, be reconsidered for some other method. Okay. So here's the deal. Okay. So the one thing that I do want to point out here, since I've got this open here, okay, there are, if I go back up to this graph here, we've got different types of trend lines you could do, okay? In our class, we're only going to deal with linear trend lines. We could do logarithmic, we could do exponential, we could do polynomial. You can see this equation changes every time I change this, okay? We could do power, we could do moving average, okay? Now, all of these have different R squared values, okay? You can see the equation changes every time. We only care about linear for the purpose of this class. That's all we're going to deal with. But you can see that there are other types of regression, okay? So that's all I'm trying to say. Now, just to prove to you, we're about out of time. Would you like me to prove to you that this is the best? Okay, here's what we're going to do. You guys remember back from your Math 1010 days or whatever, I don't know if you guys took that, but do you remember the point slope line? Point slope, who remembers what the equation was? Y minus y1 equals m times x minus x1. Do you guys remember that? No, you don't remember? Okay, so just trust me, you learned that in Math 1010 or high school. Okay? All right, so that basically says I can take any 2 points. Let's say I were to take these 2 points that are on this line. So that's the 0.99, that's this point here. And this one's at 105. That's this point here. If I use those 2 points, notice those 2 points are very similar to what I have, okay? I'm going to go through the same process that I just did. Now, what I just did is what I want you to see for the test, okay? The idea here is, I really don't have enough time. The idea here is if I were to do the same thing, this sum here, 49.8576, that's the smallest sum you will ever get. It means it's got the smallest error. If I pick any other method, such as the horizontal method or the orthogonal method, my sum is going to be larger than that. I would show you, normally I do, but we ran out of time today. So I'll show you tomorrow. We could do this again with this, and you would see that the sum would be larger. So I'll just leave it at that. You'll just have to trust me. Maybe I can do that tomorrow in our question period if you don't have any questions tomorrow. So quiz tomorrow is on 4.2 and 4.3.
And you're not going to make us memorize it.
You should try to memorize it. That's easy. It's just you have to remember it for one day. Okay? All right. See y'all tomorrow.